I'm going to go through a few of the features of the CropEye system that we've just added new to the website. So here you can see a field that's been driven, a plan that's been driven using the CropEye system where it was collecting images. If I turn on the virtual field walk here and turn on the cameras, you see all these green dots are where we took images which were then directly uploaded into our cloud. If I turn on the show all markers, then you see all these orange images too, which were taken during the operation, but stored locally on the hard drive and uploaded at a later time. So we're with these green dots, we're able to click on them and see the image that was taken by the CropEye system while it was passing over the area. As you can see here, it's a field with cabbages. So if we zoom in, we can see a better picture of that, and we can download that image if we want to show it to someone. What we've added is the enhancement button. So this enhancement triggers one of the models that we've developed using AI, which can classify different parts of the image as weeds or as crops. So you can use it in conjunction with the camera system to get an understanding of what's in the field. Here, if we click on Enhance, it says, are you sure you'd like to do this? And when we press OK, then you see you get a notification here that the enhancement has started. When it's finished running, you'll get another notification there that the enhancement is complete for that image. We can also run enhancements for groups of images for a whole task. Here you can see the operation was completed in 4 tasks. If I go to these dots here, I can press the enhancement button here, which would enhance the images, all the images in that task. Or I can download all the images in that task as well. If I go back to the one that we did before, I've actually already run the enhancement here, so we can press Show Enhancement. And as you can see, the image is then annotated with boxes, which show different things that the model has found in the image. If we zoom in a little bit more, you can see this. The first box is been recognized as a cabbage, and then this smaller box is recognizing the very center of the cabbage, where the plant is emerging from. That's called the plant stem emergence zone. We also have these blue squares here, which are dicots, which have also been picked up in the picture, which are weeds, which should hopefully be removed by any weeding that we do. If you press on the I button here, you can see the percentage coverage of each of the boxes, and the number of boxes. Again, to show you better detail of what's in the image. So what can we do with all this? Well, one thing we can do is we can map it. Once we've enhanced all the images in all the tasks, we can create a map to show us the variation in the field. I've already done that. So if I pick, say, the cabbages coverage, just turn off the images for a moment. You'll see here the coverage across the field. Here the percentage coverage has been broken up into quantile stratification, so that you can see the variation within the field is highlighted. As you can see, the light green colors here are the average, the medium percentages, whereas the blues and the reds are the reds are the low and the blues are the high. So as you can see here, this is the average is about 7%, 9%, something like that. And here in the high areas, we're getting higher coverage, and here in the lower areas, we're getting slightly lower coverage. Again, we could turn the images back on and see for one of these high areas, what it looks like, or for one of the low areas again, we can just check what part of what that looks like. Yeah, very low coverage. Okay, we can also then look at the coverage of weeds, which is also quite important. So here I'm creating a coverage map of the dicots within the field. The dicot, the values are stratified slightly different for the weeds, in that where we've got kind of a higher fidelity in the lower regions, and then as we get up above 5%, there's bigger steps, because if we've got weed coverage of over 10%, then we've got another problem. So as you can see here, there's higher weed coverage over here, but it's still not particularly high. But that's still maybe something we want to do something about. So we can go ahead and download a map. So here we have a download map interpolation, and here we can select values based on the color bands that we can see in the map. So I think I'm going to take all of this color and higher, and create a map for all the areas of the field that have above a 2.5% coverage. So then I can download that. And then I can just that downloaded then a zip file, which I'll just unzip here on my other screen. Then I can go back to create plan, and I select my field again and implement. Can then start to create a plan. I can then upload the areas that I've just downloaded, the high weed areas that I've just downloaded. So if I upload my shapefile, and then I turn those on, you can see it was these areas of the field that had the higher weed content. So then if I start planning, I can now see in the notification here that my plan is complete. So I can go to that. As you can see here, we were able to create a plan where the robotic only drives in the rows where high weeds were detected, and only works in those specific areas, thereby meaning we can do a weeding operation faster and more precisely, and only work in the affected areas, thereby saving energy too. Okay, thanks.